Hello and welcome to this video on solving trig equations with exact values. I'm hoping this will be a video in a series of videos about solving trig equations. You'll do this in a variety of ways, some with factoring, some without, some with exact values, some on your calculator. So in this one, again, we're going to focus on using exact values, and there won't be any factoring. Couple of pieces of information that you have to be fluent in to do these problems. One is the 30, 45, 60 chart for the 6 trig values. You have to be able to generate that very quickly in the margin of a test or a quiz because it's so very useful. The next is you got to be fluent in the idea of the unit circle, okay? So that is important, and don't forget, just real quickly, for any angle in standard position called theta, the point of intersection on the unit circle gives you an ordered pair that is x comma y, where x is the cosine of theta and y is the sine of theta. Okay? Now, when we use this, we're going to be specifically focused on the values that are on the axis. So, excuse me. So you're going to be focused on these ordered pairs often if we're up, in fact, using that chart. Sometimes we use this one, sometimes we use this one. In other videos, you'll see sometimes we use our calculator, okay? Also, you have to have fluency in all students take calculus, that mnemonic that represents this chart. What they are, don't forget, is it's a shortcut for understanding what values give you a positive output for a trig function given the terminal side laying in a particular quadrant, okay? So, real quickly, all the values of the big three in the first quadrant are positive. In the second quadrant, it's just sine. Third quadrant, it's tangent. Fourth quadrant, it's cosine. Well, that also implies that the other three, the other values in the quadrant, not other three, other two, would be negative. Also, with a little thought, you can probably figure out what goes on with their reciprocals. But you should have mastered that skill in a previous unit. Okay? So, let's get to work. I'll try and keep my color coding as I do these problems consistent, so you can sort of refer to the pieces appropriately as they develop. So the first thing I'm going to do here in this equation that I'm going to solve for values of theta from 0 to 2 pi, I'm going to isolate the trig function, okay? And I'm going to do that by dividing by -2. That is going to give me the result of sine of theta equals -√3 over 2. Now, a couple things that jump out at me here is one, this is a negative value. I always want to note the sign, positive or negative. And then I see if this is the output, it's got to be related to the special angles chart for 35, 45, 60. Because we know these values here are not √3 over 2. Okay? So, a couple things are going to happen here. The first is, I've kind of eyeballed that I'm going to use my special chart, but I'm also going to make a quick diagram because here I notice that the sign is negative. Okay? So what quadrant do I need to refer to is not the first, because that's where all of them are positive, not the second, because that's where sine is positive, and the third, where tangent's positive, we know sine will be negative, and the fourth, where cosine is positive, we know sine will be negative. Okay? So I know that I'm going to deal with my final answers have to be in these two quadrants. The first quadrant's always important, though, in a problem like this, because it's where you get the reference. So if you notice here, I'm looking at the value √3 over 2, and I'm realizing it says sine, and I am looking here and realizing that my reference angle is, in fact, pi thirds, also 60 degrees. But I'm using radians because it says in the problem, too. So my reference is pi thirds, but it's not my answer because I said my angle just is not in the first quadrant. So I use the reference to build two more angles, the first one in the third quadrant and the next one in the fourth quadrant. And then I record what they are. The one in the third quadrant is 4 pi thirds, okay, because it's 3/3 pi and another third, using the reference. And then the one in the fourth quadrant is 5 pi thirds, because it's 6 pi thirds, and go back pi thirds, okay? So these are my two answers. They make this equation true. You can use the store button on your calculator if it's in radians, and just check that out and see if you get a true statement for both of those, okay? Another example, we're going to look here at the same direction, solve for values of theta in the interval from 0 to 2 pi. First, I'm going to isolate the trig function, which happens to be secant in this instance. And I get secant is of theta is equal to root 2. Well, I note two things. One, that it's positive, okay, by looking at the sign here and making the decision zig versus zag. I got to go over to this chart here, which has got the special angles in it because of the root 2 value, okay? So I'm going to make an ASTC chart where secant is positive. Well, that's a little bit of a trick, but I know that for when I'm looking for secant, I need to look for where cosine theta is positive, okay? Because secant is related to cosine. They're reciprocal, so their signs are always the same. Okay, it's a clever way of using this ASTC chart to use all 6 trig functions just by knowing 3. Okay, so I know secant is positive here because cosine's positive here. I know that secant is negative in the second quadrant. Don't let that S fool you because it's relating to cosine. It's negative in the third quadrant, and where cosine is positive here, secant will be positive here too. So I know my answers are going to be in the first and fourth quadrants. So I use my reference, okay? So I'm looking for the root 2 in the secant column, and I see that my reference of theta is equal to pi quarters. So I'll draw my pi quarters, okay? And then I look and see that I need to build a mirrored angle in the fourth quadrant, okay? So I need the reference angle and its fourth quadrant relative. So now when I go to write theta equals from my final answer, I say pi quarters again, and I also say 7 pi quarters, which is this angle in the fourth quadrant, which is like going 8 quarters forward and back a quarter using the reference. These two values should be making that equation true. Okay? So let's see if we have another example, maybe one that doesn't use the special angles chart. Okay, I'm going to try and apply the same idea here a little bit. So solve for values of theta in the same interval. I'm going to isolate the trig function. Just a quick sleight of hand there because I needed to change the problem quickly. I had a sign mistake in it or it wouldn't come out right. Okay, so we've got cosine of theta is equal to 1. Okay, now I do want to note the sign, okay, that it is positive. But I also note because its output value is 1 that I'm not going to be in this special chart. I'm going to be on the unit circle. So what do? I note a couple things. Cosine is a theta is the x value on the unit circle, and I'm looking for positive x values. So now I know I have the diagram up in the right corner, but I tend to draw this for each problem when I'm solving. So where is it that I want an x value of 1? Okay, well that is in fact going to be at 0 degrees because you get 1 comma 0. And then that is the only place we're going to wind up with that. So my angle is theta equals 0 radians. And I won't say 2 pi because 2 pi is not included because of the parenthesis here. So theta equals 0 is the only value that solves that equation. Okay? Let's take a look at this next example. Same kind of technique, going to take a look at this equation and isolate the trig value. And sorry about that, same sleight of hand, because I made the same sign mistake when I made the problem. So here I'm going to add 5. Okay, negative 6 tan theta equals 0, okay? Then I'm going to divide by -6 and get tan theta equals 0, okay? And realize that when I look at that, is that there are in fact no zeros up in the special chart, so I need to refer over to the unit circle, okay? I need to do a little quick analysis here and realize if tangent is y over x, and I'm getting it equal to 0, the only way for y over x to be 0 is for y to be equal to 0. So I'll make a quick diagram and look for unit circle points where the y value is 0. Well, that is in fact going to be at 1, 0 for 0 degrees, okay? It's not on this next value on the unit circle, so I'm skipping it. But then I know that -1, 0 will also be a place that has a y value of 0. And then I record both those values, 0 and pi. They are my answers for theta. So I hope this has been helpful to you. Sorry for the 2 little equations I needed to adjust. The rest of the video was going pretty well, so I just kept them. So I hope this is a help. Feel free to practice and share with your friends.